Lesson 105, Finding Arithmetic Series. So, not sequence. This is a series. So a series is a sum of the terms of a sequence. Okay?
Hot dang.
So any sequence. So an arithmetic series is just the sum of the elements of a sequence. So we use the summation symbol.
You gotta use it.
I know. So exciting to me.
I know. I always thought that if that was in the equation, it was calculus.
So this is a Greek letter, epsilon, capital epsilon, which stands for summation. And you'll notice that they have this little, usually have those little doohickeys there. So I'm going to show you an example of a summation so you can see what it means maybe. Hopefully you can see this. Okay, the summation of 3k as k goes from 1 to 5. All that means is you're adding each term together. You start with k equals to 1, so you do 3 times 1. Then you add the next term, which would be when k is 2. So it's 3 times 2. And then you add the next term, 3 times 3. And you just keep doing that until k is 5, and then you stop. Plus 3 times 5. So then you would just add all of those products together, and you get 45. So 3 plus 6 plus 9 plus 12 plus 15. So here's an example, a different example. Find the sum. So we're summing up 2 minus k, and we're going from k equals 5 to 10. So we just start with, and we do 2 minus 5. Then we're going to add 2 minus 6. And then we're going to add 2 minus 7, and then 2 minus 8. And then we're going to add 2 minus 9. And then we're going to add 2 minus 10. So then you just figure all those differences out, add them together, and you get a negative 33. Yes, 10.
I have a question. So, if, like, with commutative property of multiplication, if you could switch all of them, so it's like 1 times 3, could you add them all together and then multiply?
Mm-hmm. So you do 1 plus 2 plus 3 plus 4 plus 5.
And then multiply
it by 3. Yep. That's called the distributive property. Yep.
Okay.
So you can factor out a 3 for this one. Okay, so,
Oh, that is distributive.
yeah.
Feel
You,
stupid now.
in other words, you can factor this 3 out of the summation symbol.
Wait, so you do...
So you take the sum of the numbers, 1 through 5, and then times it by 3.
Sweet.
Okay, we're considering something here. So we're considering. This is another, like, practice. We're just looking at this for a second. Don't freak out.
Why should we freak out?
I don't know. So if this is 1, 2, 3, 4, 5. Okay, so if we add these together, this is one, like first term, second term. So we get 48, 48, 48. So if we do, this is, so if this is 1, 2, 3, 4, 5, S okay, wait, what was I doing in this? Okay, so this, let's say this is S sub 5, a series with 5 terms, okay? This is a series with 5 terms. So we add them together, this is actually 2 times the series of 5 terms. So if you notice, it's 1, 2, 3, 4, 5. So 2 times the series of those 5 terms is equal to 5 times 48. Then we divide by 2. Which is 120. So I don't know why I wanted to show you that. So the
It's cool.
I'm trying to think if this is equal to, I think this equals 8k as k equals 1 to 5. So 8, 16, 24, 32, 40. So if I were to add all of these up, I would still get 120. But I did it this way and divided by 2 so that it was easier to do. I feel like I made it harder though.
No, I get it.
So like, so there's what's called the sum of an arithmetic series, and there's like it's in a box, you know, in your book, and it goes like this. The
Oh, I see.
sum of the first n terms,
Wait, a finite one?
yes, because it ends at n, is a sub n is n times, and then you do a sub 1 plus a sub n all divided by 2. So notice that here I took 8 plus 40, which was the last term in my sequence. So you did a sub 1, which was 8, and then a sub 5, which was 40, and my n was 5, because that was the top one, and then we divided that by 2. So 8 plus 40 is 48. We divided by 2 and got 24, and here's 5 times 24. So the sum of the first 5 terms of this particular one here is just 5 times 8 plus 40 divided by 2. So you can do this with any series. I kind of want to do another one to show you. Haha. So, no, I don't want to do that one. Okay. Oh, also we have to be able to write the summation if we have this, like if they give you some numbers together. So they're saying, okay, 20 plus 14 plus 8 plus 2 plus negative 4. We have to be able to write the summation of those in summation form. So if you look at this as,
It goes down by 6 every time. So does that
it goes down by 6, that does mean something.
K negative is the thing on top, negative 6.
Start in 26 and end it.
So we're going to do 20 minus 6. Now, if I want to do 20 minus 6k to get, so you minus it 1 time to get 14, 2 times, you're going to have to start k at 0. Or do you want to start 26?
Yeah, you can do 26 and then summation symbol and then K, or not 26, you do 2 and then over, no.
So we got summation as k goes from. So you want
No,
to,
it's, okay, so K equals, you start with 26
k,
and then
Can you do minus 6k?
No, that's not what I'm saying.
K is
I'm
1.
saying k equals 26.
Yeah. No, I like that one.
If you did that
1,
one, or if you just do k equals 26.
2, 3,
and then do
5.
And then until it's 5.
What's 26 minus 30? Is that a negative 4?
Yeah.
Well, that would work. Holly, what are you thinking of? You could go from k equals 0 to 4 and do 20 minus 6k, because then the 0 would make it 20. So you can do lots of different, and maybe the way Holly's thinking of it would work too, but I have to look at it
Yeah.
to see. But you have to be able to like plug in your k and get each one.
Well, yeah, I know.
Okay, so this is actually, I want to go back up here. This is actually called, sometimes called the partial sum
Can
up
K
to
be
the nth
negative?
term.
No, that won't work.
Can K be negative?
It's what, this defines what k is right over here. So you could go like from k is negative 3 to whatever.
Oh, so the bottom is where you start and the top is where you go to?
Mm-hmm.
That's
Where you
just
end, that's
how
what-
many terms is in the thing?
Yeah, that you're adding together because it's a summation. So this up here is sometimes, I don't know if it's in here, the partial sum. Oh, no, it's just if the series is infinite, you could use this to be a partial sum. So you can get some of it.
Yeah.
Okay. So I need to do,
Yeah,
You need a number then.
now we have to give another example of problems you might have. So if it says find a certain term, so we want the 20th for sequence 5 plus 12 plus 19 plus 26 plus and so on. So I feel like you could use that partial sum formula. So we could say that a sub 1 is 5. A sub 20, you can figure it out because you do 5 plus
7K.
7
K.
times,
19 plus 1.
yeah, 20 minus 1, which is 19. Because we're adding 7 both times.
Yeah. Wait, I have a question.
And we only do it 19 times because we're getting to the 20th one.
Nah, it
So
is. That's
on an
138.
infinite
'Kay.
one, does the thing look like? I have a question, but I need to do it.
So we're
Does it
doing
look like
the partial sum. So where's my formula? Oh,
Does it equal?
I
does
wrote it
look
right
like
here.
that when it's infinite?
mm-hmm.
Okay.
So n, and then it was a sub 1 plus a sub n divided by 2. So we know our a sub n is 138. So we want 20 terms. So we can do 20 times, and then we have our first term 5 plus 138 divided by 2. Oh, we can divide 20 by 2 and get 10 times 143. So the partial sum for the series up to 20 terms is 1,430. And that would give you your answer. One more example. Find S of 17 for, and now we're going to write it in summation symbol. K equals 1 to 17 of 5k minus 4.
I forgot what's that 17.
So, oh, it means what is this partial sum of this series up to 17?
Okay.
Okay, so we just do the first one, which is 5 times 1 minus 4, which is 1. That's our a sub 1. Then we times it by 17. 5 times 17 minus 4, so you do
60 plus
170,
25.
85. So you do 5 times 17 minus 4, which is 85. And that's our a sub 17.
Wait, how is 5 times 17? Isn't it 81? Because 5 times
Oh, yeah.
17 is
81.
85,
Sorry.
and then minus 5.
Yeah.
No, you're good.
81.
I just did.
You keep writing S sub 17 and then A sub 17.
Okay, so a sub 17 is different. That is the 17th term that you are adding.
17.
S sub 17 is the actual sum when you add those 17 terms together. Okay? So you have to know the first to the 17th in order to find the actual sum, which is just 17 times, and then we do 1 plus 81 over 2.
41
And then this will give me the sum.
times 17.
41 times 17, which is 697.
Really? Only 600?
Okay, that's it. Let's answer.